Today we are going to solve systems of equations by elimination again for the second time. So let's take a look at the types of problems that we'll end up seeing. Here is a problem in which we have x's and y's lined up, and constants are lined up as well. This is the type of problem that we want to use elimination for, especially this problem, because all I'd have to do to solve it is to add these two equations together at this point in time, because the y's will end up canceling. You see, x plus 2x leaves me with 3x, and the y's cancel out. So I only add the equations together when I get a term to cancel. And that's the whole idea here, is that we want one of the variables to cancel so we can solve for the remaining variable. So we have 3x equals 9. And then from there we can go ahead and divide by 3, and we'll have our answer. So in this case, x equals 3. Well, we still have to substitute. And what makes the elimination method a little bit more tricky is that we don't have a variable solved for like we do in substitution. So we have to take this 3 and substitute it back into either equation. And I guess this one would be the easiest one, that top equation. So I'll rewrite it as 3 plus 3y equals 15. So you have to do a little bit more work to solve for the remaining variable using this method. And so from this point, I have to do some opposite operations. I have to isolate the y term. So I'm going to subtract that 3 from both sides, leaving me with a 3y equals, and here I have 12. Well, I go ahead and divide by 3, and we'll have our answer for y. And so y ends up equaling 4. So x is 3, y is 4. We write the answer as an ordered pair, 3, 4. Let's take a look at the next problem. This one I can't just add the two numbers together. Can't do that because I can't add the two equations because I don't cancel anything out. So again, this is a system, so I'll draw a little brace around there. But if I add this, I get 3x. If I add this, I get 2y. So I want one of those variables to cancel. So I look at it, and I think the easiest way to do this, to get one of the variables to cancel, is to cancel out the y's by multiplying by -1. When I do that, I can rewrite that new equation down below. It would be -x minus y equals -2. See, all the signs ended up switching. And so from that point, we can go ahead and add these two equations together. And now we get these y's to cancel. And so all I'm left with is an x equals -3. So that gave me my x value right away. Well, I can take that -3 and substitute it. I'm going to choose to substitute it back into that original equation on top before I modified it. So I'm going to put it right in place of that, in place of the x. Let's move it in place of the right variable. In place of that x, solve for y. So let me rewrite that equation again so you can see that a little better. So it's x plus y equals 2. So again, I'm going to take that -3, which is what x is, and I'm putting it in place of that original top equation, right in place of that x. So it'd be -3 plus y equals 2. And so from there we can just do that one opposite operation, add the 3 to both sides, and we would have our answer. And so y equals 5. So there's my answer, -3, 5. Well, one more type. This one's a little bit tougher because we can't just multiply by a negative to be able to cancel out the x's or cancel out the y's. We need to multiply actually both equations by a value. Again, so this is a system. So when you see that brace around the system, around the two equations, they're asking you to solve the two equations for where they intersect. So I'm going to try to eliminate my x values because one is negative and one is positive already. So if I'm going to eliminate them, I need them to be the same number. So I need to multiply the top equation by 3, the bottom one by 2. And what that makes is a -6x, and over here I have a positive 6x. But I don't just multiply the x's, I multiply every number by that value. So negative, or 3 times negative 1, 3 times 5y, 3 times the negative 2x. Do the same thing with the 2. 2 times 3x, 2 times 2y, 2 times 11. And then rewrite the two equations. So I'll go ahead and do that. And I've got negative 6x. Now I'm looking at the top of one here. So 3 times negative 2 is negative 6x. 3 times 5y is positive 15y. And this all equals negative 3. 3 times negative 1. Down below, 2 times 3x makes the positive 6x. 2 times 2y makes positive 4y. And bring down the equal sign. 2 times 11 makes 22. So now I'm ready to add those equations together because the x's will now cancel out. So what I'm left with is just the y term, and that makes 19y. And over on this side, I subtract because they're opposite in sign, and that makes a positive 19. So I can go ahead and divide by 19, and you'll see right away what your value of y is. So y equals 1. Well, that's the y term. We still need to find x. So now I'm going to take one of these two equations. I'm going to take this bottom one, the second equation. I'm going to rewrite that problem right here. 3x plus 2y equals 11. And I could have taken any of these four equations, really. But I'm just looking at them, and I think it's easiest to just take that one and put it in for this y right here. I'm going to get the value of x quicker this way. So I go ahead and bring down that 3x. And then it's 2 times my 1 I'm putting in for y equals 11. So this makes 3x plus 2 equals 11. So now I have to do that opposite operation to solve for x. So I'm going to subtract the 2. And then from there, I got that 3x left over. 3x equals 9. So from that point, you just need to divide by 3. You'll have your answer. And x is going to be 3 in this case. So we've got x, we've got y, we've got our ordered pair. So x equals 3. So we'll write down the ordered pair as 3, 1. And there is our solution. So elimination is a great method. I use it most of the time. Whenever x and y are on the same side and we've got x's and y's lined up, it's a great method to use. I use substitution when a variable is by itself, or easy to get by itself. Next part, we'll have a word problem plus 2 other different types of special systems, I guess we could call them, where we end up with different answers rather than one point.